So again, we're on section 4.7 of our notes. Problem number 1 says, literally it says, find the angle whose sine is 1/2. So I'm going to draw my triangle right here in quadrant 1. If this is a positive number right here, no matter what function that is, if that's a positive number, you're always going to draw it in quadrant 1. In a minute, we'll talk about what to do if it's negative. But if it's a positive number, you're always going to draw one triangle, and you're going to draw it right there in quadrant 1. The angle you're looking for is right here. That's the angle I want to know. I know that its sine is 1/2. Remember, sine is opposite over hypotenuse. So the sine is 1/2. Well, that makes this side √3. Can anybody tell me how big that angle is?
30.
Yeah, absolutely. That's a 30-degree angle because it's across from the 1. So the answer to this problem is simply 30 degrees. That's all there is to it. Okay, let's look at the next one. It says the angle whose cosine is √3/2. Now remember, I just told you that if this is a positive number, you're always going to draw your picture in quadrant 1. Okay, it's not confusing at all. If that's a positive number, we're drawing it in quadrant 1. Now this time, the cosine, we're looking for this angle, and the cosine is √3/2. So adjacent over hypotenuse is √3/2. Oh my gosh, that makes that a 1. How big's that angle?
30.
Yeah,
30.
that's 30 again. Yep. So the answer to this problem is also 30. Now, I don't want you getting freaked out. Remember, we don't have many options. We have 30 and 60 and 45, right? So it doesn't bother me at all that I got the same answer for these two problems. I'm going to get that answer a lot. So that just happens. You're going to get that answer a lot. All right, let's try the next one. Remember, when you see that little -1 that looks like an exponent, that means you are finding an angle. So now we are finding the angle whose tangent is √3. Now that's positive, so there it is right there in quadrant 1. You're always, for these problems, with the little -1 here, you're going to draw one triangle, and you're always going to draw it in quadrant 1 if that's positive. The next one's negative, and we'll talk about what happens when it's negative. But when it's positive, it's quadrant 1. Tangent is opposite over adjacent. Remember, these are all always fractions. So if you want to put it over 1, that might be helpful. So opposite over adjacent is √3/1. That makes this 2. And how big is the angle this time?
60 degrees.
Yes, thank you. That's a 60-degree angle this time. So the answer to the question is 60 degrees. Remember, this notation, this little -1 thing, means find the angle. So the answer is going to be an angle. It's 60 degrees. Now, the next one is also an angle, but we're not going to draw it in quadrant 1. This is where things get a little bit more complicated. You have to do a little memorization. So maybe at the top of the page or along here, I want you to write the following rules. If that number is negative, so if the number is negative, and by number, does everybody understand I'm talking about this guy right here, the number in the problem? If the number in the problem is negative, sine, tangent, and cosecant are in quadrant 4. Cosine, cotangent, and secant are in quadrant 2. So remember, if the number is positive, you're going to draw it in quadrant 1 every time, no matter what. If the number's positive, it's going in quadrant 1. However, if the number is negative, we have these rules we have to follow. If it's a sine, it's going to be in quadrant 4. If it's a cosine, it's going to be in quadrant 2. So these 3 go into 4, these 3 go into 2. All right? And that actually, there's a reason for that. It has to do with the curves themselves. But we're not going to go into all that. We're just going to memorize that sine, tangent, and cosecant are in 4. Cosine, cotangent, and secant are in 2. So, I'm going to draw my triangle in quadrant 4. Because this is a sine, and this is negative. And that's the rule. Now, opposite over hypotenuse looks like this. Can you kind of see how the negative fits down there, guys? Doesn't that make sense? And this side would be 1. And how big is this angle right here? Oh, shoot,
45.
I just wrote it down. It's 45 degrees. This angle right here is 45 degrees. Because you have a 1, 1, root 2 triangle. The answer to the question is negative 45 degrees. Does it make sense to you that I said negative 45 degrees? Yes.
Is it?
Oh, go ahead. Go ahead. What was we saying?
Is it because it's looking at the negative one?
No, it's because I'm going down. Remember, when you go down, your angles are negative. When you go up, they're positive. Like this one was positive 60. But when you make your angles going down, they're negative. Okay? So the answer is negative 45 degrees. All right, let's try this one. This time, I'm going to erase this. I hope you have that written down. I'll leave it for just another second, but get those rules written down. So we have the angle whose cosine is negative 1/2. Okay, so it's a cosine and it's negative. So that means I have to be in quadrant 2. So I'm going to draw my triangle in quadrant 2. Remember, every triangle you draw, kids, is going to be one of these. Do not be drawing random triangles. You're always going to draw one of the butterfly bow ties. Now the cosine, here's the angle right here. The cosine is adjacent over hypotenuse. This tells me I'm looking for the angle. I have the cosine, so I have the sides, I have adjacent and hypotenuse. That makes this root 3. How big is this angle then?
60 degrees.
Exactly. Now, put your thinking cap on. The answer isn't 60. 60 is over here.
Negative 60.
And actually, it wouldn't be negative 60 either. Negative 60 would be down here. The answer
Plus or minus?
is the red angle. Remember, we have to start. I love your guessing, by the way. You guys are doing great today. You have to start here and go around to the hypotenuse. So how big would that red angle be? It's not 60, not the red one.
150.
It's not 150 either, although you're really close.
180.
180
It's
One-
160.
180 brings me to here. That would be 180. So all the way to here would be 180.
130.
Oh, we're getting closer.
The one would be 120.
It would be 120. 120 degrees. How did we settle on 120?
Because 120 plus 60 equals 180.
There you go, my friend. That's it exactly. We know that this is 180 over here. But we didn't go that far. We stopped with 60 to go. Right? So that means 180 minus 60. So that's 120 degrees. So the answer to this problem is 120 degrees. Gotta have those thinking caps on for sure. All right, now we got another one. The angle whose tangent is -1. I'm going to put that over 1. -1 over 1, make it a fraction. So I got a triangle somewhere, and I know opposite over adjacent is 1 over 1. Opposite over adjacent is 1 over 1. That's a negative number, though. So where will I draw it? Where do I draw tangents that have a negative number?
Quadrant 4.
Exactly, quadrant 4. That's what the rules say. You don't get to decide. You just have to follow the rules. So negative tangent, a tangent with a negative number, is in quadrant 4. So I know opposite over adjacent, 1 over 1. So I recognize that triangle. This would be root 2. And how big is that angle?
45.
Yep. So what do I put in the answer blank? Be careful. That angle is below the x-axis. So we won't say the answer is 45. We'll say the answer is? Negative 45. Very good. So the answer to the problem is negative 45. Because the angle is below. It's coming down.
Wait, this is 4.
Yes.
How are you knowing, like, what, is it only, like, how do you know when to subtract, like, the 180, like we did on the problem before?
Well, what's the
Like, why is
difference
this one just
between?
45 degrees
Well,
when
what's
you
the difference
subtract
between
it?
these two problems?
Well, yeah, but like,
Yeah, that's it. They're in different quadrants.
oh, that's all that matters.
Yeah, you got to pay attention to which quadrant you're in. And then your angle starts, you start measuring on the positive x-axis. If I have to get all the way over to here, that's different than if I'm just going down.
Yeah, okay.
All right, what's next? Okay, now we got a positive one again. Letter G is positive. So remember, if they're positive, no matter what function it is, sine or cosine or whatever, I draw it where, if it's a positive number.
Quadrant 1.
Yep, so I'm going to draw my triangle in quadrant 1. I know the sine opposite over hypotenuse is root 3 over 2. That makes this one. I recognize that triangle. We worked with that triangle a lot. We recognize that. How big is the angle then?
60.
Yep. And when you're in quadrant 1, isn't that angle just the answer? You don't have to make it negative. You don't have to do anything to it. That's just it. Quadrant 1 is easy. So the answer is 60 degrees. All right, now we have another negative. So we have to first of all stop and figure out where we're going to draw the triangle. So it's a negative number. Where will we draw it? It's a cosine.
Quadrant 2.
Yep, this is a quadrant 2 problem. So whatever my answer is, whatever angle I get, remember, this one's going to be the answer. But I need to figure that one out first. So I know that the cosine is root 3 over 2. That is adjacent over hypotenuse. That makes this a 1. And how big is that angle now? In the triangle, that one right there. That's where you got to start.
30.
30. 30 is not the answer, though. The red is the answer, because you got to start here and go all the way. It's 150. That's right. So the answer to the question is 150 degrees. For those of you that are still confused, remember, if you went all the way to here, it would be 180. We didn't get to 180. We stopped with 30 to go. So 180 minus 30. Perfect. All right, let's look at the next one. This one is a little bit freakish because that number is a 0. Now I want you to think about that for a minute. If I tried to draw a triangle, tangent is opposite over adjacent, I'd have to have the opposite side being 0. Can I draw a triangle with a 0 here? No. What do I do if I can't draw a triangle?
You gotta draw a circle.
Exactly. So I'm going to draw my circle. I'm going to let the radius be 1, like I always do. And then I'm going to look at these points. Okay, there are my points. And I'm going to figure out where around that circle, opposite over adjacent, or y over x, is 0 over 1. So look around there. Remember, it was 0. Well, 0 over 1. Where am I going to get 0 over 1, guys? Where's that going to happen? Where will y be 0 and x be 1?
In the right one there.
Right here, right? What angle is that? Like this is 90, this is 180. What's this? What angle is this?
0 or
Yeah,
360.
exactly. And we always go with 0 instead of the big 360. You're right, it's also 360, but we always go with 0. So the answer to this problem is 0 degrees. 0 degrees. This is the angle that if you put y over x, you get 0 over 1. Beautiful. Aren't we going to have the same situation here, guys? Aren't we going to have to look at our circle? Because if you didn't, if you tried to do a triangle, which I understand trying to do a triangle, but if you tried to do it, the opposite side would have to be 0, because this is opposite over hypotenuse. And you can't have a triangle with a side of 0. So since I can't draw a triangle, I'm going to look around my circle. This time, though, it's y over r, because that's what sine is. Sine is y over r. Okay, so look around the circle. Remember, r is 1. We set it up so r is 1. Where is y 0? Isn't it also right here? Isn't y 0 here? So the answer to this problem is also 0 degrees. All right, so what are the big takeaways there? The big takeaways are this notation, no matter whether it's cosine or tangent or whatever, always means you're looking for an angle. So your answer is going to be an angle. If this number is positive, we draw our triangle in quadrant 1. If it's negative, we got our rules that we follow about where to draw it. And if it's got zeros in it, we're going to need to get our numbers from this circle, because we can't draw triangles if the sides are 0. Now there's one more piece to this, and that's in the next section. So let's look at the next section. They look terrifying, but they really aren't. They're pretty darned easy if you take them one step at a time. So let's look at this first problem, and now on page 38. Oh, we're getting close, guys. So sine tangent inverse 3/4. Find the exact value. Exact value means no calculator. So I'm going to pretend for a moment that this isn't here. I'm going to do what I always do, and that is start inside the parentheses. That's what we do in math. We start inside the parentheses. Now this says we're looking for an angle. That's what that little -1 means. This is an angle. And I know that's a positive number, so I'm going to draw that angle in quadrant 1. This is exactly what we just got done doing. I've covered this up. I'm not doing anything with this thing yet. So opposite over adjacent is 3/4. Okay, now wait a minute. This is not going to be a 30, 60, 90, or 45, 45, 90, is it? No, these aren't the right numbers. However, can I do the Pythagorean Theorem and find my hypotenuse? Yes. So would you do that for me? Would you do a squared plus b squared equals c squared? And see if you can come up with c, your hypotenuse?
Is it 5?
It is 5. Very good. Anybody have a question about where the 5 came from? We need to get that 5. We need to do the Pythagorean Theorem right so that we have that side. 9 plus 16 is 25, and the square root of 25 is 5. Okay, good. Now, I still have no idea what that angle is. I don't know. You don't. None of us know. We don't know what that angle is. The good news is we don't want the angle. We want its sine. Can you look at this picture and tell me what the sine is? What is the sine of this angle?
3/5.
Yes, and that's the answer to the question. That's it, guys. It's that easy. You draw a picture of this angle. So we did that. We needed the Pythagorean Theorem to find the other side. We had opposite and adjacent, so we did the hypotenuse. And then the question said, find the sine. So we looked at the picture and said, okay, the sine is opposite over hypotenuse. Great, great work. Let's look at the next one. Now this is very, very similar. Do the parentheses first. So, just ignore that cosine out there. That makes it confusing. We're focusing on the parentheses. So when I see this notation, I'm going to draw a triangle. When I see that's a positive number, I'm going to draw it in quadrant 1. That's what we've been talking about today. all right? Now, sine is opposite over hypotenuse. Does that make sense to everybody that I would label my triangle like that? All right, do the Pythagorean Theorem and tell me what you get this time for the adjacent side. Remember, 13 is your C. Hypotenuse is your C. What'd you get?
12.
Yep, you did get 12. Very good. Because it's x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. X squared equals 144. And x equals 12. Very good. Now, the triangle is drawn, and I want to know the cosine. The cosine in that picture is what? Here's your angle. What's the cosine?
12 over 13.
Yes, indeed. So these problems look very scary, but as long as you do it one step at a time, they really aren't too bad. All right, let's look at the next one. Now remember, we're starting inside the parentheses, so we're covering up that for a minute, and we're doing this. Now, whenever you see this, it means you're going to draw an angle. You're going to draw a triangle somewhere. Now, this is negative, so it's not going to be quadrant 1. It's a negative, and it's a sign. So which quadrant will I draw it?
4.
Yep. Those are our rules, guys. I know you don't have them memorized yet, but you should have them written down. So we're going to draw this angle in quadrant 4. We know the opposite is negative 4 and the hypotenuse is 5. That's what it says, opposite over hypotenuse, sine. Okay, go ahead and do your Pythagorean Theorem. A squared plus b squared equals c squared. Remembering that the 5 is the c, this is your c. So a squared plus b squared equals c squared.
3.
Absolutely, it's 3. Now you're ready to answer the question. What do we want to know? We want to know the tangent. So looking at that picture, what is the tangent?
Negative 4 over 3.
It is. Are you starting to get the hang of this, guys? It's not bad. All right, so let's look at the next one. And see if you can draw your picture for me. We're going to start always by drawing a picture. Let's see, I'm on D, right? So see if you can draw your picture. Which quadrant are you going to draw your picture in?
One.
Yeah, easy question. That's a positive number. So it doesn't matter what function you have. If you're a positive number, you're in quadrant 1. Remember, tangent is opposite over adjacent, so that's why I've labeled it the way I have. Shout out a hypotenuse when you get it. That's your C in your Pythagorean Theorem. It's going to be a radical this time, which is fine.
Square root 13.
Square root of 13, perfect. And now I want the cotangent. So look at that picture. What's the cotangent?
Is it 2 over 3?
Tangent would be 2 over 3. Cotangent is the reciprocal, remember? So it'll be adjacent over opposite. So it'll actually be 3/2. Okay, David, does that make sense to you?
Yeah.
Okay. All right. Next one, here we go. Don't be alarmed when there's a radical in the problem. They happen all the time. It happened here. Don't worry about the fact that we've got a radical. I'm going to draw a picture first. Good news is that's positive. Root 7 over 4 is positive, so I'm just going to draw quadrant 1 and be done. Adjacent over hypotenuse, that's cosine, so adjacent over hypotenuse. So a squared plus b squared equals c squared. So root 7 squared plus b squared equals 4 squared. What's root 7 squared?
7.
Yep. Plus b squared equals 16, so b squared equals 9, and b equals 3. What's the answer to the question? What is the sign in that picture?
3/4.
Exactly. All right, I want you to try the last one all by yourself. All by yourself. See if you can come up with an answer. What is the tangent of the angle whose cosine is 3/4? See if you can come up with an answer to that. Okay, anybody got an answer yet? We'll work through it, but share your answers. What'd you come up with?
Root 7 over 3.
Root 7 over 3 is one answer. Okay, anybody come up with a different one? Oh, well maybe that's the right answer. Let's see. You draw an angle, it's positive. You put the 3 here and the 4 here. So a squared plus b squared equals c squared. You got root 7 and the tangent is. Good job. Very nicely done. Anybody have a question about that? You didn't get root 7 over 3. Okay, well, now we're ready for 4.8, which is just a couple more word problems. We have done some of these already, so this should be easy for you. But 4.8 says, draw a picture, write an equation, solve it. Round to the nearest hundredth, and I'm going to add, be sure to label your answer because this is a word problem. All right, so here we go. Find the angle of elevation of a bird to the top of a tree. All right, so here's our tree. Here's the bird in the top of the tree. And the bird is 18 feet above the ground. And the point is 100 feet from the base of the tree. So here's the point, and that's 100. Now, I want you to look at that picture and tell me if you have a question about why I put the numbers where I put them. Does that make sense to everyone that the 18 and 100 are where they are? So the question says, find the angle of elevation of the bird. Find the angle of elevation of the bird. So do you remember when we talked about this before? Every angle of elevation or depression, it doesn't matter what it is, elevation or depression, it's going right here. So that is my question. That is what I want to know. So the problem said draw a picture. Now it says write an equation. When you write an equation, you are going to use either sine, cosine, or tangent. All right, so what do you think? Yeah, this is going to be a tangent. And we know it's a tangent because why? Right? How did you know tangent?
Opposite adjacent.
Exactly. With respect to this angle right here, opposite adjacent, that's tangent. We know nothing about the hypotenuse. So we're not going to use a function that uses hypotenuse. We're doing opposite and adjacent. Good. Now, these are the kind we just talked about where the variable is the angle. So that's when you need your special tangent button. We'll go to our calculator. I do not know if who's been using your calculator, but go to mode and make sure that degree is highlighted. And then type second tangent, 18 divided by 100. And that angle is 10 point, how am I supposed to round? 100th? Actually, it'd be 10.20 degrees. So the answer to the question is 10.20 degrees. Type second tangent, 18 over 100. I'm using my calculator here because, well, this is not a special triangle, so there's no way I can find the angle otherwise. But remember, it's a no calculator problem when it says find the exact value. This is not exact, it's rounded off. I can't find the exact value. I need my calculator. All right, hopefully that looks somewhat familiar. Let's look at B. Find the distance from a worm on the ground to a bird in the top of a tree. So we got a bird in the top of a tree again. And he's looking at a worm on the ground. The angle of depression is 24 degrees. Remember, technically the angle of depression is up here, but we're never going to draw that. We're always going to put it right down here. And the tree is 19 feet tall. And I want to know the distance from the worm to the bird. So take a look at how I set my picture up. And now is the time to ask if you're not sure about what I did. Okay, let's write an equation. That's the picture. What will my equation be this time? Sine, cosine, or tangent?
Sine.
Yep, and you know it's sine, Eli, because why? How do we know it's sine?
Opposite hypotenuse.
Exactly. There's your angle, opposite hypotenuse. So sine 24 equals opposite over hypotenuse. Now, I want to make sure you see the difference between where the x is in this equation and where the x is in this equation. When the x is hooked to the tangent or the sine, or when it's hooked to the function, then you have to do your special thing. This one's not. This is just a plain old x. So I'm going to go ahead and solve it like a plain old equation. So I'll multiply both sides by x and then divide by sine 24. So when I go to my calculator, it's going to be 19 over sine 24. Just type that in. 19 divided by sine 24. And the distance from the bird to the worm is 46.71 feet. Okay, all right, one more in this section, then we got some drawing to do, it looks like. How tall is a flagpole? So here's my flagpole. How tall is it if it casts a 23-foot shadow when the angle of elevation is 32? So again, the first part of the problem is getting the picture drawn. Anybody have a question about the picture? Okay, what's the equation then? Somebody have an idea for an equation?
Tangent.
Yep. It's going to be a tangent problem because the tangent of 32 equals opposite over adjacent. Opposite over adjacent. So I'll multiply by 23. Type it in on my calculator. 23 tangent 32. 14.37 feet. Is the height of the flagpole. Okay? All right, we have two more problems and we'll be done for the day. These two are just drawing. So we're not going to need our calculator. We're not going to be doing any trigonometry. We're not writing any equations. We're just drawing a picture, getting ready for the next chapter where we'll have to do stuff with this. Now, I'm on part 2 now, on the back of page 38, number 2, where it says draw only. Notice it's talking about a ship on a course. So that means I'm going to use my compass setup. Remember that? We haven't done this in a while. This is our compass setup. Okay? That's different than our regular setup. And again, I didn't write the rule book. This is just the way it is. So when we have a compass problem, this is the setup we need. So you might want to draw this over to the side just to remind yourself that that's our setup. All right, so here we go. Here's the ship at the port, right there at the beginning. He sails for 4 hours on a course of 125 degrees. So look at your compass, 0, 90, 180. Wouldn't 125 be down here somewhere? It doesn't need to be perfect. Just have it down here somewhere. And then mark this angle like this, 125 degrees. That's his course. Now, this might be new to you, I don't know. It says the ship is traveling at a constant speed of 10 knots. A knot, in this kind of problem, is a nautical mile per hour. So a knot is just a speed. It's like saying he's going 10 miles an hour. It's just kind of ship language or aviation language for speed. So 10 knots means he's going 10 miles an hour. And he's going for 4 hours. So I'm going to label this 40. He's going 4 hours at 10 miles an hour. 4 hours at 10 miles an hour. Knots are miles per hour. They're nautical miles per hour. But for our purposes, we'll just think of it as a speed miles per hour. All right, so now he's here. So I'm going to set up a new compass right here. And he changes course to 195 degrees. Well, look at your compass. 195 degrees would be just past south, right? Wouldn't it be right here? 195? So I'm going to draw right here. And this angle is 195 degrees. And how long will that be? Well, look at the problem. He went 1 hour. So if he went 1 hour, wouldn't this be 10? 10 miles an hour for 1 hour? Done. That's it. That's the picture. So a course of 125 to start, and then a new course of 195 to finish up his journey. One more problem, here we go. I'm going to use the same compass. Okay, he's flying at a speed of 250 miles per hour for 3 hours on a course of 50 degrees. So look at your compass. Where am I going to draw his course? If it's 50 degrees, aren't I going to be right there? So I'm just going to draw his course just like that. And this is 50 degrees. Remember, we start due north, 50 degrees. Now, how long am I going to make that? Remember, he's going 250 miles an hour for 3 hours. So how long is that? He goes 250 miles in every hour. So how far would he go in 3 hours?
750 miles.
Yep, 750. Now he's going to change course. I'm gonna set up another compass here because he's changing direction. So here was his original point. He came up here. Now he's gonna change direction. And now he's gonna be on a course of 350 degrees. So here's your compass. Where are you gonna put 350 degrees? Isn't it just right here? So that course is going to go like this, and this is 350 degrees. And how long is that vector? How long is that? He's 300 miles an hour for 2 hours. How long is that? He goes
600.
Yep, 300 miles an hour for 2 hours. That's 600. So his first leg of his journey was 750 miles. And then the second leg of his journey is 600 miles. The first part of the journey was a course of 50 degrees. And the second part of the journey was 350 degrees. So almost all the way around. And that's all you have to do is draw it. Just draw it. Okay, well, I got good news and bad news. The good news is we're done for the day. The bad news is we did 2 sections, so we're going to have 2 assignments due on Thursday. We'll have the 4.7 and the 4.8 assignments. They're both very short, so it shouldn't bother you or worry you in any way, but they're going to be due on Thursday. All right, does anybody have any questions for me? I'll see you back. I'll see you on Thursday, right? Yeah. Because I don't think I see you tomorrow, but I will see you on Thursday. All right, anybody have any questions for me? All right, you're free to go. Have a wonderful day.
Thank you, Miss Ford.
Bye.